find their workspace, Ruth. If you guys don't remember, today is the assembly for homecoming court, I think, things like that. Any assembly is right after period 2, but it's not as long as chapel. It's only 20 minutes. For those of you that have been here for a while, it's like a pep rally in the sense of it's short, so the classes are a little bit longer than chapel schedule. But the assembly is right after this class. You're going to go straight to the gym. I'm going to try and do it both ways, so I'm going to go ahead and start, but I'm not going to talk. You guys can keep working. You have to find the vertex and the zeros. Did anybody try the old-fashioned factoring way? You really hope it's 3 and 6, but why can't that work? -3, -6 makes a positive 18. Well, so if you did try 3 and 6, it was a good idea that it worked, but it doesn't. You would need a -3 and a -6 to make -9, which multiplies to be a positive 18. answered both questions with completing the square. I'm going to go ahead and also show how it could be done by plugging in. And then we'll go ahead and see how many of you guys chose each one and chose it successfully, meaning it was able to work out. X minus h, that would be a positive 9/2. Good idea to check with the formula. Positive 9/2. For those of you that did do plugging in, how do we find k? Yeah. Plug in the h, right? Common denominators right now, in case you're wondering. Which one, just by looking at the board, took more work? Which way? Completing the square or formulas? Which one took more work for zeros? Yeah, completing the square took more work. Quadratic formula actually wasn't that bad because you couldn't simplify this anyway, so complete the square took more work, but which one took more work for the vertex?
Quadratic formula.
The plugging in way. Yeah. So for this problem, was there really one way that was shorter than the other?
No.
Not to answer both questions. Not to answer both questions. How many of you guys naturally started by completing the square? Okay. About half. How many of you guys naturally started, I'm assuming it's the rest, but let me see your hands, by plugging in into formulas, like negative b over 2. Okay. Some of you didn't try the problem, I suppose. That's weird. Coming back. Remember, be real, be honest, there's no judgment. For those of you guys that completed the square, how many of you guys actually got to at least one of the two correct answers? 2, 3, okay, 4, 5. For those of you guys that plugged into formulas, how many of you got to at least one of the two right answers? Ironically, just taking our class, it was about equal. Meaning, it was about half and a little bit less than half, as far as about half chose to try completing the square, a little bit less than half chose to plug in, and the others of you, I have no idea. Thanks. From those that tried completing the square, about 3 or 4 got at least one of the right answers, and from those that tried plugging in, 3 or 4 got the right answer. So, Can anybody be real with me as to where it got tricky? Because this was a kind of tricky problem. Just in general, Chris, where did it get tricky?
For the completing the square, once when you got to like the square, I'm assuming you square rooted both the top and bottom denominator. Close right there.
Oh, right here.
Yeah.
Yeah, I square rooted 153, which I couldn't do, and I square rooted 4, which was 2 common denominator. Let me put it together.
Right.
It was that simplifying that was hard.
It just didn't.
Click. Yeah. I understand. But if you do have a big old square root of a fraction, Chris said it, you can square root the top and the bottom. When I was able to square root 4, it became 2 common denominators put together. But yeah, that is tricky. What else, Jake?
I just have confusion on words like dry revised the way you're putting in that.
For complete the square, like where everything is going.
Yeah.
Let's review that, because like half of you wanted to complete the square and somehow you got stuck. So let's review what I did. First, I separated the x squared x terms from the negative 18, right? Because this guy didn't cut it, we tried to factor, it wasn't good. How did I start building my x minus h squared plus k? I wrote the x. Why did I write minus? Yeah, look at that middle term, right? The coefficient. Steal the negative, and what did I do to the 9? Cut it in half. So the arrow down steals the sign, cuts the number in half, and then the arrow back up, what did I do to the 9 halves? I squared it. And then what I do here, I need to offset, because I added, now I need to subtract. And then if you think yesterday we had to double check what was in front to see if it changed the value, but does it change the value? No. It's just times 1, which is why I just wrote the exact same thing over there. Does that make sense, the down and then up? Yeah. So steal the sign, cut in half, squared as you come up, and then offset, or balance out. And then after that, it was, how many of you guys would at least be real and be like, you know, the common denominator thing and like multiplying big numbers, it's hard for me. Okay, like over half the class. So some of you, do you have to multiply big numbers on either side? Yeah. You have to multiply big numbers on either side. This one, you kind of do it all together because you get common denominators and you get the 72s and the 153s. This one, it's kind of spread out in that you don't have to do a lot of that in the quadratic formula. I think the worst math fact in the quadratic formula for this one was 4 times 18. Is that right? The 4 times the 18 was the biggest one here. And then like that addition. That was the hardest part here. But then didn't we have to do like 9 squared and common denominators? So you have to do it. Complete the square, you do it right away. And plugging in, you kind of have to do it later. So do you have to, if multiplying isn't so good, do you have to actually take the time and do it? Yes. Now, I agree. And I don't apologize, but I do a lot in my head. I do a lot of mental math. But I do want to let you know the following. Whenever I see 18 times 4, that had to happen in both ways, right, guys? Both approaches, we had to do 18 times 4. I don't do this just in my head. I don't jump to an answer. I'm not a calculator. Some people are. They literally jump to answers. I don't. I literally do this in my head. And I do 4 times 8 is 32, and I carry the 3, and 4 times 1 is 4 plus 3 is 72. That's what I do in my head. Not everyone's like that. Some people can jump to an answer, but I don't. So realize I'm just a little bit faster because I can do this in my head. You just do it on paper. But should you know how to multiply numbers? Yes. Jacob, what else?
On the left side, when you started writing with that, how did you get from that second level to the
This one?
lower? Right there.
How to get from here to here?
Yes.
Hold on. With the square roots or before?
After.
Square roots.
Yeah,
Okay.
to the next level.
I was trying to find the zeros. So after I completed the square, I had to set the y equal to 0 and solve. So what you have to do in solving this equation over here, the first thing is I added the 153 over 4. So I added that to the other side, hence why I had 153 over 4 and this one disappeared. Then the next thing I had to do is take away the squared because there was no number to divide. So I took away the squared by plus or minus square rooting. Then all I had left was x minus 9 over 2 because I had taken away the square root and the square. So then I just added, at which point I had to get, oh, I just wrote it, sorry. He has a square root and he doesn't. So therefore, this guy just comes outside, this guy comes on his own, they're separate because they can't combine. And that's when I did what Chris talked about, which was, I saw the square root as really a square root of the top and the bottom. So root 153 stayed, I don't know him, I can't simplify him. But root 4, I can simplify. Square root of 4 is 2, common denominators, so I put it all together. But the first step was setting equal to 0. I add, I square root, and then I add. That makes sense. It was this part? I was running out of room, so I could do this off to the side. Square root of 153, all over square root of 4, all over 2. And once I wrote that, then they had the common denominators, so I put them together. Now, technically, square root of 153, there are factors of that one. 3 goes in how many times? 51?
51, yes.
So those of you that were wondering, it's a little long division in my head. 3 goes into 15 5 times, 3 goes into 3 1 time. 51, but does 51 have anything that goes into it? 1, 2, 3, 4, 6. Ooh, 3 goes in. Oh, struggle. Does 9 go into 153? Ah, we could have simplified that radical. Man. Did anybody else simplify 153? Did anybody get that? No? It's okay, I didn't get it either. I'm not going to write it and mess up all of our answers. Let me just show you the following. I know. 153 looks like it couldn't, huh? 153. 9 goes into 15 one time. Then you have 63, 17 times. Oh, struggle. That's a hidden one. So we should have made those all 3 root 17. Oh well. That's okay. We'll just say it's true. Alright, kiddos. The workspace. Hopefully it revealed some weaknesses. Not in a bad way. This was a hard problem and I got stuck on the way I thought that I preferred. Let's go ahead and let's grade our evens really quickly in our homework. That way you guys can maybe pick out a few other weaknesses. Remember, not in a bad way, in a I don't quite have this perfect, I need to keep working to master it way. Remember? That's why we do this. It's not to make you feel bad about your weaknesses, it's just to go ahead and help you identify so that you know what to work on before a test comes. Let's check our evens, let's grade our evens. Remember, look for the answers. What were you able to get right? What were you not able to get right? Maybe if we have time, I can go over 1 or 2 questions if a lot of us have shared questions. If your questions aren't the same as other people's, which I won't know unless you ask them. That's what after school math lab, during lunch times, etc. would be a great time to come bring me one and be like, I got this totally wrong. Can you help me? I don't know what to do. I'll get a whiteboard and we'll do that one-on-one. Number 4, I think it's the axis of symmetry. Is that what that is?
Yep.
Number 6, if you have a negative leading coefficient, then you're going to have a maximum. If you got that wrong, negative means concave down. And look at my mouse, concave down has a high point, has a max. Number 10 was supposed to graph, or match I should say, match A. The odds of those matching you could have checked in the back. Okay, number 24, I'm going to try and make them a little bit bigger. You had a lot of stuff you were supposed to do. You were supposed to, oh, now he's down here. Okay, you were supposed to graph him, right? Does he factor nicely? Oh, they didn't even factor him. He factors nicely. He's x plus 17 and x minus 1. So you could have factored in pretty nicely and gotten the zeros without having to use the quadratic formula or the vertex formula. Or completing the square. You could have just factored in. If factoring is possible, it's the fastest way to find zeros. Zeros are going to be at positive 1 and negative 17, just from factoring. But the vertex, they completed the square because that's what they're trying to show you works. You could have plugged into the formula. If you did, hopefully you got negative 8, negative 81. Either way you solved it, remember it's x minus h. And then do you guys remember the axis of symmetry? Did anybody look at their notes at least once last night? Or once in the homework? Oh, I should see all the hands on that one. The axis of symmetry, we wrote down yesterday, x equals who?
H.
x equals h. All you had to do was look at the notes and say, oh, hey, x equals, take the h, done. Then you go ahead, graph your point, graph your zeros, swoop, there it is. Okay, number next one. This one was tricky, because what did they do? They gave you the answer. Wait, what? They gave you the answer, and they were having you find the problem? What? But that's an H, that's a K. Did you put them in the H spot?
Yes.
Did you put them in the K spot? Who didn't you know? So we're stuck? No, because they gave us the point -2, 4. And if it's a coordinate, if it's an ordered pair, isn't this an X? Isn't that a Y? So where did they put the -2? In the X spot. And where did they put the 4? In the Y spot. Can you solve for A?
Yes.
Don't be afraid of those fractions, take them step by step, piece by piece. So plug in H, plug in K. Oh no, I don't know A. All right, plug in an X, plug in a Y, solve for A. Then they were just asking you to say, this was the equation. This was the equation where these two things are true. I'll still have that equation showing in case you need to check that final, answer. Number 58, I think he's our last even. Oh, we still have some more down there. 58, you could have factored him. Because, could you have done quadratic formula? Yeah. Could you have completed the square and set equal to 0? Yeah. So you could have factored, or done quadratic formula, or completed the square and set equal to 0. All of them would have gotten you, should have gotten you, if you did them correctly, the same answers of 1/2 and -3. Oh, the football one, I forgot about the football one. Oh, that's fun. Okay. Question, they gave you the equation, right? And the equation was the height of the football? All right, so pause. What happens when a football is punted? It goes up, and then gravity brings it what? Right back down. Pause. Where was it at the moment it was being punted as far as distance from the ground?
1 point.
At 0? Is it on the ground when you punt it?
No, 1.5 something. You don't punch it off.
Nick, help us. How do you punt it?
You just grab it.
Right. You hold it down, right? You drop it, and then you kick it. I mean, okay, obviously not exactly like that, but you drop it and you kick it. Like, you don't drop it. You drop your hand, and then you kick the ball. It's not in the little thing, and it's not on the ground. So, if I was drawing a model of this, and if this was my time, and if this was my height above the ground, did they say S or F or G or who knows? Okay, height above the ground. Okay, at the beginning, which means time is equal to 0, it's something off the ground. It's not on the ground, it's off the ground, it's up. It's going to fly up and it's going to fly down until it hits the ground and then maybe bounce around a little bit, but that's the path of the ball, right? Okay, now look at the equation they gave you. Is it a quadratic? Yeah, it's a squared, right? X squared? What's the leading coefficient? Negative, because it needs to be concave down for the ball to go up and then come back down, right? Okay, what did the first question ask? A said or asked?
How high is it when you kick it?
When it's punted, right? Is that right? How high is the ball when it's punted? Okay, so what am I going to know, or what am I going to, wait, this is it, right? This is what I want to find? So I want to find the y value when x is 0. Oh, so for letter A, all you had to do was plug in 0? Yeah, that's it. Pause, help me out. Was it an f of x? Was it an f of t? Was it an s of t? What was the name of the function they gave you? What was it? F of x? Okay. So this is f. They didn't name it t, they named it x. Cool. So just plug in 0. That's it. Letter B, what did they ask? Maximum, like how high it goes? Oh, how are you going to find the max? What point is that? Yeah, what is it? That's the vertex. How do I find the vertex? I need H and I need K. Could you complete the square? Yes, but wasn't that a horrible equation? Could you have done negative b over 2a and maybe it would have been easier?
Yeah.
Yeah, and if you're gonna go to your calculator anyway, which some of you might because the numbers in this one are kind of nasty, and I would understand that. I probably wouldn't expect you to do this one by hand, but if you did, great job. If you went to your calculator anyway, isn't there a max feature?
There it is.
You could have always done that, at least you get the answer. Maybe you didn't have all the work, but maybe you're like, I think this one's gross, I think she was, use the calculator. Okay, so you could have either done complete the square, or negative b over 2a, or find the max on your calculator. All you have to do is find the vertex. What's letter C ask? Horizontal distance? Like how far down the field it goes? Okay. When does the ball stop going through the air?
There.
What's true here? Do I know the x?
Yes. Why is
No.
What do I know though? Y is
0?
0. So on C, all you're doing is solving for the zeros. Using complete the square, or the quadratic formula, or the zero feature on the calculator, if you were assuming I would let you use it. Is there a D?
No.
So then let's go check out the answer, because some of you would have just frantically started writing because you didn't do this one last night. And I'd rather you understand what to do than frantically write down all of their work. Question, did they use a calculator or did they do everything by hand? Oh, but wait, what were they giving the answers in? Ah, the stinkers, they went to their calculators. If they went to their calculators anyway, what could you do and not have to do everything by hand? Use the max feature, use the zero feature, and then plugging in 0, well that's easy. 0 plus 1.5. There's A, there's B, there's C. Final answers, write them down quickly. A is 1.5. B, that's how high. B is 104.02 feet. C is 228.64 feet. If you guys were awesome and already used your calculators and did the rounding the way I would have liked, you probably did 3 decimal places, which means your answer is even better than the book. Alright, if you have those 3 answers down, I'm making this go away. If you need any more help than that, you can come talk to me, but look at the board. I told you how to do each and every one. Kiddos, normally I would say, let's go over questions on homework. And I am going to ask really quickly if there is 1 or 2 that were like, oh please, I was waiting to ask you this and I don't know how to do it. Is there anything? 76 is usually the worst one on this one, but was there another one that was bad? Was there a problem in homework that had a 1/4 in front?
Yeah.
Please wait for me. Josh, take those glasses on. I have no idea if they're with me or not. Thanks, they're cool though. Is there a homework problem that has a 1/4 x squared? Can you find it for me real fast? 33. I don't know about you, but I think that's kind of one of the worst ones to complete the square with, besides 76 that has horrible numbers in it. Noah, can you read that to me?
F of x equals 1/4 x squared minus 2x minus 12.
What were the directions on that one? Did they have it find the standard form or the vertex or the zeros? Oh, sketch the graph, so like, all the stuff. Okay. I'm gonna go ahead and get you guys, if you wanna keep your homework spirals out, if you did get stuck on 33, he's a hard one. I'm gonna kind of talk them out just a little bit, but I do need to get you guys started in 2.2 notes. So I'm going to give you a little hint on 33. So have your notes ready. We're going to talk through one little thing about 33, and then I'm going to work them out the way that I would, because I know Calculator doesn't necessarily do stuff the way like I would, right? I just want to make sure you guys know how to start 33. And I want to show it both ways. So I'll draw this. Okay, If you guys want to pause the notes for just 1 second, remember, I'm gonna work this out, and I'm gonna finish it on the board so that you can take a picture of it, check it out. I think it was one of the hardest complete the square ones, because it has a 1/4 in it. And then as I finish, you guys will take notes, but you're watching right here just for the first step. In complete the square, you have to get a leading coefficient of 1, which means the 1/4 has to come out. Kiddos, when we factor, pause, when we distribute, what operation are we doing when we bring stuff into parentheses? Multiplication. So when we factor, what are we doing? Division. So one way of thinking about it is I'm taking the x squared term and I'm dividing by 1/4, which is why just the x squared is left. Now the problem is, when you take the -2 and divide 1/4, that's hard for a lot of us. Some of us could mental math it and say 1/4 times who would get -2, and some of us would get the -8x. 1/4 times what coefficient would get a 2? Oh, 1/4 times 8 gets me the 2. But for others of us, we'd actually be thinking about how do I take 1/4 away from 2? Think of it this way, 2 divided by 1/4 is 2 times 4/1, which is 8. That's what you would need to actually do when factoring 1/4 away from 2. Divide the 2 by the 1/4, which means multiply by the reciprocal, which gets us 2 times 4/1 times 1 is 8. Either way, you can get this missing coefficient. For those of you guys that were plugging into the formula, when you went to plug in, you had -b, which would be a +2, all over 2 times a. What did you need to remember? Hopefully simplify. But then how do I do 2 divided by 1/2? Yeah, you can say 2 divided by 1/2 is 2 times the reciprocal 2/1, which is 4. Now, I'm going to go ahead and keep solving this out my way. You guys go ahead and start taking notes. I'm just showing you how to start this problem, because the start was the hard part. And I'm assuming from what you guys could or couldn't do at the beginning of class today, that very few of you could actually do this one on your own last night. I'm not saying Calc Chat couldn't have helped, I'm just saying it would have been rough. So, keep going. Let me go ahead and solve this out. Oh, that's randomly changed. If you really want to understand how to complete the square and or use the formulas to plug in. Yes, someone's choir music is randomly in here, I don't know why. I know some of you guys are fine. You might want to take a picture of that one before you leave today. Because it was tricky in a whole different way. The answers weren't super hard, but the 1/4 made everything funny. All right, kiddos. We only have a few minutes left. You guys hopefully have this page already down. Long story short, I said chapter 2 is all about polynomials, like the first half, and then rationals. It's the majority of polynomials, a few rationals at the end. We covered quadratics in 2.1, now it's time for higher polynomials. And we talked about in section, I don't even remember, chapter 1, we talked about the basic parabola, the basic cubic, and that was it. But we have to get beyond the basic. So, here's the idea. If you guys have the picture, let's go ahead and put phones away. And let's go ahead and focus back on it. So, we have to get beyond just the easy ones. There are a couple characteristics first of all, but this whole section is about how much can we figure out about polynomial graphs. Now let me tell you right now, without calculus you can't figure out everything. But we can figure out a lot. We can figure out the main idea. So, first of all, we know that no polynomial will ever have any jumps, any breaks, any holes, or any vertical asymptotes because they're always continuous. But not polynomials, always continuous, always smooth curves. We never have to worry about any of the weird discontinuities that can happen in other graphs. Second of all, we know even if it's a quick turn or a more drawn out turn, we know that all polynomials have smooth turns. No sharp turns like absolute value. We're going to keep going though. Those are two characteristics. Here's something else we know. If we had time, as long as the leading coefficient was positive, I would have you get out your graphing calculators and graph an x squared, and graph an x to the 4th, and graph an x to the 6th. And you would get something kind of like that. Question. What changes as the power gets higher for x as we go through even powers? What changes? The shape? Not the shape per se, more the steepness. How quickly, how high it goes. How high it goes and how fast. The shape in the sense of they're all just going to be parabolas, which some of you might not have realized before. If I keep going x to the 8th, x to the 10th, it's going to keep on being parabolas, just what are they doing as the powers get higher? They're getting narrower, right? Now, odds, same thing. You guys should know the cubic one from last chapter, at least roughly. What happens as I do x to the 5th or x to the 7th? They get narrower again. But once again, the basic shape is still the same. And what I want you to zero in on is what's going on at the end. What's going on with the arrows? Evens, they agree. Odds are opposite. Evens, the ends agree. Odds, the ends are opposite. So whenever we're dealing with a polynomial, in general, before all the weird middle terms come in, that x to the 6th plus x to the 5th minus x to the 4th plus x cubed, you can have all these extra terms, but just from the degree alone, you can know what's going on at the end by asking yourself, is it an even degree or an odd degree? And is the leading coefficient positive or negative? Tomorrow we're going to talk a little bit more about the leading coefficient test and about the end, but this is basically where section 2.2 starts. Tomorrow, our goal is to go ahead and dive into 2.2. Today our goal was to cover questions on 2.1. See if you kind of had chosen a way to solve and then been able to use it. But tomorrow we gotta dive in. See you guys later. Maybe you can start homework. But I would say catch up on other classes tonight. You're gonna have to Precalc over the weekend. Bye guys. Assembly, go to the gym. Going to the gym, Yeah.
I got a math joke to show you.